This is Dr. Mantesh. In this tutorial, we would like to discuss about the last, that is fourth experiment of part A. So this is all about latches and flip-flop. So this is just to synthesize the design and compare the synthesis report of D, SR and JK. We'll open up with ISC, that is Xilinx 4.14.7. I have any version is okay in that matter. So we'll start with new project, new project. We'll start with say D flip-flop. So first thing first, what is the difference between flip-flop and latches? You should understand. Latch is level triggered, flip-flop is edge triggered. Okay, just we are going to see all those variations in the simulations. Okay, we'll keep the same thing, make sure that this is very long, and finish. Take a new source, Verilog module, D flip-flop, finish. It is just a 2-3 line code. You can copy it, but I have a source code already. So what I do, I'll go here and I have D flip-flop. Fine. So we have D flip-flop, D as input, D stands for data. It has got reset, clock, Q and QB. Then we'll copy it here, Control A, Control V, then save. Try to check if there are any errors or not. Anything to be modified, I'll just go through. This must be reg because it must store the values of Q and QB as well. Okay, just make sure that you have reg. Always passage of clock. If reset equals to 1, then Q is equals to 0. Q bar is anyway opposite to that of. So simultaneously updating. Actually, these must be written in concurrent statements. Anyhow, it's okay at this moment. Then these must also be written in concurrent statements, or this QB must be written outside the always module to update. Anyhow, it is also okay, no problem. Everything happens with respect to clock, and this is now coming after passage. This reset is coming after passage, so this is synchronous reset. Okay, fine. Synchronous reset, D flip-flop. Next one, we'll try to simulate it. I can simulate in the same way what we did it, but let me make it short because we have to cover other two flip-flops. We'll take test bench, Verilog module, DFF underscore TST, something like this would be very meaningful. Control A, delete. I have a code, or else you are supposed to write the code here. These codes I am going to share anyway. This is D flip-flop. Fine. Next one, we have simulation. So it is already taken inside the as an instance. Then we'll try to simulate. So what is this test bench? It is easy to read, nothing, no complexities involved in it. This is where you are trying to generate the clock. Every 5 nanosecond clock will be not of clock, that is the period of clock will be 10 nanoseconds. So in 1 microsecond run you are going to get 100 clocks. So better you make it in 100 nanoseconds, something like that, so that you will get only those many clocks. And every 30 nano, 40 nano, 20 nano, these values are going to be changed. Flip-flop, all of you know. Let me check the waveforms. Here I have to click the waveforms. Go to view. So if okay, first you go for clock. You arrange as you do in the truth table. Okay. So it is synchronous reset, so I am putting reset after the clock. Everything depends on the clock now. If rising edge of the clock, D is 0 here, so Q is 0, Q bar will be not of it. Now, the difference between latch and flip-flop would be very simple. Let me take a small change in the code. So you are getting output, correct output for this. What I do, I'll go and change. Instead of flip-flop, I'll try to make it as latch. The latch is very simple. You don't have to put pause edge. You simply put clock. So it will become level triggered. First thing. So any change in the clock will do this. Okay. A small change required for this flip-flop to become latch. If clock equals to 1, this must be observed carefully, and one more end statement I have to put. So this is all about latch and flip-flop. Next one we have the SR and JK. We can start with JK. So this is JK. The main difference between JK and SR is this has got toggle, whereas SR will not have toggle when both are 1-1. Let's go and do this simulation. We can take new project. JK flip-flop. Next, finish, and then new source, Verilog module, DFF. Next, finish, Control A, Control V, Control S. This is toggle. You can write comments. The first one is no change. This is the truth table. You can say no change. Second one is, what is it? It is reset. Third one is set. Fourth one is fourth state is toggle. So you can write something like this, which is a good practice, and you will understand okay what is what. You don't have to buy at everything. When Q is 1, it is set. When Q is 0, it is reset. When Q is going to continue to be as Q, it is no change. When Q is not of Q, it is going to be toggle. So okay. Next thing about the simulation, will create or will simply add, because I have a file already. JK flip-flop test bench. Fine. It has been already added. Then you simply do simulation. So it must have consisted all possible cases 00011011, and click on waveform, default waveforms, view all, zoom to fit 0001. So where is the clock? You make it first. Okay, fine. Then JK. Where is JK? Here. There are two things. I am trying to remove it. One, clock and JK. Q bar reset. So reset also can be put after this. 0 0 0 1 0 1 is reset, 1 0 is set. Then 1 1 is toggle, but it stopped here because of the reset. Okay, after reset in the next, it is synchronous reset. In the next rising edge, it has stopped. There are two toggle conditions you can able to see here. After that it is reset, so output is Q is equal to 0 all the time. Q bar is not of Q. So this is JK. Next one is SR, where you will get something else here instead of toggle case. Take new project. What you are supposed to do is do all these simulations, and you should compare the output synthesis report. Fine. I am trying to add simply because I have already. Then SR flip-flop. SR is not there. Okay, here it is. Okay. So I can consider SR here as well. Control C. Then take new one. Verilog module. SR flip-flop. Next, finish. Control A, Control V. So instead of Q and Q bar, you can put X, which is indeterminate, or Z also you can put, but it is X is correct. So this I would have changed to SR. Fine. Any errors it will show. So X is not declared. Okay, fine. At least Z we can have. Okay, X 1 bit you have to declare something like that. One bit binary B1 tick 1 tick B X. So I'll take a. Okay, only one small change is here. So we'll try to add JK flip-flop test bench. It is not added because it is saying JK. So what we do, we are supposed to change it to the module instantiation. We should call it as SR. That's it. Now it is added. And do the simulation. Can you see now? I'll just try to delete this clock. When both are 1 1, so we are getting X. So this is the difference in SR. Anyhow, we have not changed the name. Instead of JK, we are supposed to change it to XR. Let me do it now. So you just replace anywhere. If it is JK, Control F. Find JK. I have options to replace. find and replace with SR. Anywhere replace all. This is too simple. Same thing here. Anywhere if it is JK is there, what I do, Control F, find and replace. Wherever JK is there, you replace with SR, replace all. Can you see everything became SR? You just do one more time. This is about one more small change I would like to do. Instead of JK flip-flop test, we have written it as this test. Okay. This is file name, nothing wrong in it. The file name must be changed afterwards, and you do synthesis. This is SR flip-flop for you. Okay. Synthesis will not come because it has not got any port. I don't want to synthesize the test bench. So what you are supposed to do is compare synthesis reports of SR, JK and D flip-flop. Simulate behavioral model. Fine. Here we go. So only change, instead of toggle we made it X, forced unknown. This is SR flip-flop. Okay, I think you understood. I'll share these codes. For synthesis, what you're supposed to do, as given in the syllabus, you are supposed to compare the synthesis reports. So what you do, you take you just delete this test bench and do synthesis. So once you do synthesis, go to summary, copy this table. Here it may not be so visible because it is taking 111, everywhere, but in the cadence the differences are very clear. So you just compare these things, you copy down this table, synthesis report. You can also check critical path delay if you wish. Okay, so data path QP to QB is the critical delay, 2.419 nanosecond. Same thing you can do with respect to same thing you must do with respect to JK flip-flop. You open, go to file, open project, do JK flip-flop. Sorry, not this one. Close project. Recent projects also simply go for D flip-flop. So the delay and path you have already seen, the synthesis. So you will just check and compare now. Fine. I did the simulation already. So what you are supposed to do, you go to summary and write down these things. Can you see? A small 1 1 instead of 6 you have 1 1 1. So there is nothing much change, but in the report there may be a change in the delay. Earlier it was 2.419. Now we don't know. The data path is different. Earlier it was QB to QB, and 3.253 nanosecond is the delay. Okay, so that was different, this is different, so you should make a table for it, and you have to tabulate the results of SRJK. Thanks for watching.